Good day, SS2 Technical Drawing students. In our last lesson we learned how to project points and lines onto the principal planes. Today we go a step further and learn how to find the true length of a line. This is one of the most tested topics in WAEC technical drawing, so pay close attention. When a line is inclined to both the horizontal plane and the vertical plane, its projections in both views appear shorter than the actual length of the line. This shortened appearance is called foreshortening. To design structures, manufacture components, or cut materials correctly, engineers must know the actual, true length, not the foreshortened length shown in the plan or elevation. There are two main methods for finding the true length of a line, the rotation method and the auxiliary plane method. Both are used in WAEC examinations, and students should be comfortable with either. The concept is rooted in the fact that when a line lies parallel to a projection plane, it shows its true length on that plane. So if we can mathematically rotate or reproject the line until it is parallel to one of the principal planes, we will see its true length. This is the core idea behind all true length constructions in descriptive geometry. The rotation method works like this. Suppose we have a line AB in space and we have drawn both its plan view, up, and ', elevation view, A'B'. We want to find the true length. In the plan view, we treat point A as a pivot. We rotate point B in the plan view until the line AB is parallel to the XY line, so the rotated B lands at a new position we call B1. This rotation keeps the length of AB constant, we are just changing its direction. Now at B1 in the plan, we draw a vertical projector upward to the elevation view. In the elevation, we draw a horizontal line from A' across to meet this projector, the meeting point is B1'. The line from A' to B1' is the true length of line AB. Why does this work? Because by rotating the line in the plan until it is parallel to the XY line, we made it also parallel to the VP, and lines parallel to the VP show true length in the elevation. Remember, rotate in plan, project up, measure in elevation. Alternatively, we can rotate in the elevation until parallel to XY, project down, and measure in the plan. Both give the same true length. The auxiliary plane method uses a new projection plane specially chosen to be parallel to the line in question. Here is how it works. Given the plan view up and the elevation A'B' of line AB, draw an auxiliary reference line X1 Y1 parallel to the plan view up. This auxiliary line represents a new vertical plane that is parallel to AB. Now project points A and B perpendicularly onto this auxiliary plane by drawing projectors at right angles to X1 Y1. The distances of the points from X1 Y1 in this auxiliary view equal the heights of the points above the HP, which we read from the elevation. Mark A1 at a distance equal to the height of A above HP from X1 Y1, and B1 at a distance equal to the height of B above HP from X1 Y1. Connect A1 to B1, this is the true length of AB. The auxiliary plane method is particularly useful when the rotation method becomes cumbersome, for example when dealing with lines in complex positions or when finding the angle a line makes with the HP or VP. The angle between the true length line and the X1 Y1 auxiliary reference gives the angle of inclination of the line to the HP. Practice both methods until you can choose the faster one for any given problem. To summarize, lines inclined to both principal planes appear foreshortened in both the plan and elevation views. To find the true length, we use either the rotation method, rotate in plan to be parallel to XY, project up, measure in elevation, or the auxiliary plane method, draw X1 Y1 parallel to the plan view, project heights from elevation, connect for true length. In WAEC examination questions, you will be asked to find the true length and often also the angle the line makes with the HP or VP. Remember, the angle with the HP is found from the auxiliary projected from the plan, the angle with the VP is found from the auxiliary projected from the elevation. Always work in pencil, show all construction lines lightly, and label clearly. Next week we tackle true shape of planes. Keep practicing.